I was mesmerized by the introduction, and I'm pretty much sure my children, you too were mesmerized by the same. So now we are very much curious to understand where exactly all these things came from. Now, basic analogy is not to understand how it came, but who made it come. So let me start with the basic idea of Dalton's atomic theory. Well, look at this smart guy who's sitting right in front of me, beside me, in fact. Hey, guy, what's up? I know, I'm talking about you. And he was called as John Dalton. He was the father of atoms. Now, about John Dalton, he was the first person to propose the atomic theory in the year 1808. 2016. 1808. Look at the timeline. Salute to this guy. So basically this guy had some idea. Let me share it with you. His entire theory's first point was matter is composed of extremely small, hard and indivisible particles called atoms. So you can see the atoms of solid, liquid, gases. Solid are very tight and liquid are a little bit flexible enough they can take the shape of the water, and gas they are free, just like a random motion. So what you can see is what you studied in your 9th standard, 10th standard, nothing big about it. Second point says that atoms of a given element are identical. You can see the hydrogen, it looks same, yeah, of course same, Judwa, PR. Third point, they have a characteristic mass, they have specific mass. Atoms of different elements, they differ in size, they differ in mass, they differ in other properties. And they cannot be divided. Okay, see, atom is a fundamental element, you cannot divide it. No matter how much ever you hammer, will it get divided? No. So coming towards the next characteristic, they combine to form molecule, which is smallest unit of a compound. Now atoms, they join together to form molecules. CO2, one Cl2O, CO2. Now that is called molecule. Now molecule is the basic unit of compound. Atoms of different elements combine in simple whole number ratios to form a chemical compound. Now what is this whole number ratio and how is it formed? I will show you very soon. But in the chemical reactions, atoms are combined, separated or rearranged. Let me show you by these awesome videos how compounds are really formed. So chemical compounds, let me give you a very nice awesome demonstration wherein two atoms combine with third to form something different. Let's say oxygen. Oxygen, when it is an isolated atom, a very beautiful atom, you can see how electrons are dancing around the oxygen. Okay, so let me take this blue dot as oxygen. Now dear students, I have hydrogen in front of me. So to represent hydrogen, I have another kind of atom, another color, and let me take the color as orange. So what happens next? That's the chemistry. Two hydrogen, two separate atoms, when they come closer and closer with the oxygen, let's say what kind of reaction takes. There's no reaction, there's a combination of H2O, two hydrogen, one oxygen. And when this two hydrogen, one oxygen combines, what you get is a beautiful, serene and awesome water. So, dear students, two hydrogen along with one oxygen gives you a beautiful compound. There's a source of life, water. Quite thrilled with it, aren't we? Now proceeding with the limitations of Dalton's theory. Limitation, yes sir, you have many limitations, but what kind of limitation we have, sir? Let's see. The very first limitation is, with the discovery of subatomic particles like proton, electron, sir, you are wrong. Atom is not the fundamental. Beneath the atom also we have seen quite a different world, didn't we students? And he could not explain why certain substances all containing atoms of the same element should differ in their properties. Example, charcoal, graphite and diamond. They are made up of carbon atoms, but still their properties are quite different. Let me show you the example. Oh yes, that's charcoal, that's graphite, and then it's diamond. Three different things, but they are made up of all carbons. So this could not be explained by my dear Dalton. And atoms of same elements are not similar in all respect. They may vary in mass and density. Come on, they are called as isotopes. And I'm pretty much sure you must have seen the example like two isotopes of mass number 3 AMU and 35 and 37 AMU, different kind of AM. Chlorine is one such example. In chlorine you have two isotopes, Same atomic number but different atomic mass number. This couldn't be explained by Dalton. So what next and what next? Let's see in our next module. So here is a famous quote by Dalton. Matter, though divisible in an extreme degree, is nevertheless not infinitely divisible. That is, there must be some point beyond which we cannot go in the division of matter. I have chosen the word atom to signify these ultimate particles. Thank you, Mr. Dalton. We'll come back to you very soon. See you all, students.